Welcome to The Explainer. Today, we're setting the stage for a truly high-end mathematical masterclass. We are going to unpack a theoretical framework that proposes to completely rethink the fundamental constants of standard cosmology. Forget everything you thought you knew about the physical makeup of space, because we're looking at the universe entirely through the lens of pure mathematics.
To kick things off, I want you to listen to this profound claim from our source material. The universe is an error-correcting mathematical matrix, not a fluid of exotic particles. That is a massive statement. We're about to explore how empirical physics, the stuff we normally try to measure with telescopes and colliders, might actually be completely replaced by pure arithmetic geometry.
Okay, let's dive into this. The whole foundation of Lagos field theory argues that standard cosmology is fundamentally flawed because it relies heavily on unsupported empirical inputs. Instead, this Adelic Langlands program suggests that things like cosmic expansion, gravity, and quantum states are strictly forced into existence to stabilize the universe's arithmetic source code across what's known as the Adel ring. You can basically think of the Adel ring as a master mathematical structure that elegantly ties all number fields together.
So here's our syllabus for today's tutorial. We're going to cover 1. The mathematical paradigm shift, 2. Resolving dark energy algebraically, 3. Calculating galactic acceleration constraints, 4. The geometry of the cosmic background, 5. Big Bang nucleosynthesis yields, and finally, the universal error correction matrix. We're going to unpack these equations step by step to show exactly how this framework operates.
All right, let's start with section 1, the mathematical paradigm shift. To do this, we really have to unlearn the assumptions of standard Lambda CDM cosmology first.
What's really interesting about this matrix is the stark contrast. Standard cosmology relies on a static vacuum fluid pressure for dark energy, invisible halos for dark matter, and an empirically fitted expansion rate. But in the Adelic mathematical reality, that invisible dark matter is replaced by uncompensated geometric backreactions. Static dark energy becomes a dynamic infrared cutoff mass gap. Basically, everything empirical is systematically replaced by exact intrinsic clock frequencies.
Let's move right along to section 2, resolving dark energy algebraically.
This is where we run into the notorious fine-tuning paradox of the cosmological constant. In standard cosmology, dark energy is just a static constant. But here, the cosmological vacuum energy is highly dynamic. Let's walk your eye through these variables. Notice the Q infinity term in the inverted square root? That represents a scalable global conductor. As the space-time volume of our macro-universe expands, this number field naturally grows with it. And because it sits right there in the denominator, the expansion of the Adel ring automatically drives the effective vacuum energy down towards zero. The fine-tuning problem is literally erased by expanding number fields.
Which brings us to cosmic expansion. Look at the global cosmic wave packet on the right. In this framework, the distribution of physical matter is modulated by a specific cosmic sine wave. Expansion isn't just some empirical fit to make telescope data work, it's a rigid structural requirement. It acts as an intrinsic clock frequency derived directly from the primary arithmetic zero, denoted here as gamma 1.
70.6736 kilometers per second per megaparsec. I want to pause deliberately to let this number land. In standard cosmology, researchers are constantly arguing over the Hubble tension, basically the mismatch in measuring this exact rate. But here, there's no argument. This exact Hubble constant is mathematically derived as exactly 5 times that primary arithmetic zero. It entirely bypasses empirical gridlock through pure arithmetic.
So, that covers cosmic scales, which leads us into section 3, calculating galactic acceleration constraints. I want you to consider something for a second. How does a galaxy hold together if we completely remove dark matter particles from the equation? So, the crucial point is found right here in the macroscopic spacetime metric equation. Space isn't just warped by visible mass, it receives a mandatory topological correction from what are called regularized Quillen metric curvature forms. Essentially, at the edges of a galaxy, paths tracing across the Bruhat-Titz tree cause active inertia groups to fail to terminate. This creates an uncompensated phase shift, a persistent structural weight that perfectly mimics a dark matter halo. No invisible particles required. And when we uniformize this topological mass line, something amazing happens. If you follow the flowchart, notice how the equation for A sub 0 uses the exact same primary zero, gamma 1, and the Hubble constant we literally just calculated. The structural coupling collapses into a scale-invariant relation. Dark energy and galactic acceleration are driven by the exact same arithmetic zero.
And here is the absolute mathematical punchline. Evaluating that formula yields 1.09 times 10 to the negative 10 meters per second squared. This pure arithmetic derivation flawlessly matches the empirically observed Mond acceleration constant. It yields flat galactic velocity profiles naturally, completely without the need for exotic dark matter particles. Absolutely wild.
Okay, let's transition back to the early universe. Section 4, Geometry of the Cosmic Background. We're going to look at the cosmic microwave background as a thermodynamic readout of pure mathematics.
Standard cosmology typically views the acoustic peaks of the early universe as linear plasma fluid oscillations, but this brilliantly illustrates how the acoustic peaks at multiple moments 222, 330, and 392 are actually rigidly, non-linearly locked to the ratios of the non-trivial zeros. It is the precise geometric signature of mathematical branching structures, the Burhat-Titz tree again, projecting directly onto the celestial sphere.
Let's unpack the unramified angular power spectrum equation here. Notice the logarithmic derivative logic. It reveals how the fundamental mass gap forces a strict infrared cutoff, causing low-level quenching. You see, standard cosmology struggles with this so-called low quadrupole anomaly, but here, the trace formula strictly prevents populating the lowest multiples. It smoothly drives the spectrum to zero at large scales through pure arithmetic dissipation, completely removing the need for arbitrary cosmic inflation models.
Moving right along to Section 5, Big Bang nucleosynthesis yields. Let's shift our focus to the chemical composition of the universe.
So the parameters for Big Bang nucleosynthesis in the freeze-out operator equation are absolutely not stochastic. They are thermodynamic signatures of mathematical values known as local Swan conductors. Watch this. By substituting explicit prime number weights, specifically 8 and 2 from the 2-adic and 3-adic fields, into this algebra, the nuclear freeze-out threshold locks at exactly 0.753 MeV. This flawlessly matches actual physics observations, the point where weak interactions drop below cosmic expansion, but it is derived purely from algebra. We can methodically break down this logic. Step 1 fixes the statistical nucleon equilibrium, the ratio of neutrons to protons, at 0.1796, using that 0.753 MeV threshold. Step 2 applies the primary zero clock frequency we learned about earlier to govern the beta decay duration, bringing the ratio down to the active fusion baseline. And Step 3 yields the final algebraic mass fraction. The universe synthesizes exactly 23.78% helium-4. Why that specific amount? To guarantee that the discrete wild prime data streams remain perfectly phase-locked. Chemical evolution is quite literally a macro-scale mechanism of quantum error correction.
Which perfectly tees up our final part, Section 6, the universal error correction matrix. We are going to tie all of these distinct phenomena together into one cohesive proof. According to the Arthur-Selberg trace formula, there are very strict mathematical constraints on our universe. The continuous spectrum absolutely forbids odd parity magnetic-type components from existing. The regularized variety is affine and flat, meaning there are zero native topological defects. On top of that, Hadamard matrix stabilizers configure discrete variations that map onto the topological cycles of the celestial sphere, enforcing strict symmetric parity and variance.
Visually, the eradication of the odd parity branch, you can see it aggressively crossed out right here, means there are exactly 0 negative geometric classes available to balance a primordial anomaly. This mathematically isolates the E-mode phase density. Because of this missing balance, the inflationary gravitational wave paradigm of standard Lambda CDM cosmology isn't just challenged, it is mathematically falsified.
Let's move to the next slide and see how this all builds together. This is the ultimate aha moment. A grand, unifying synthesis. Standard cosmology essentially dissolves here. Expansion, gravity, and quantum states are all interlocked outputs of a single mathematical code. The dark energy mass gap, the Mond galactic acceleration, the Hubble expansion rate, and the acoustic peaks of the cosmic background, they all radiate outward directly from a single primary arithmetic zero, 14.13. Just one primary number dictates the entire fault-tolerant mathematical code of our universe.
So, what does this all mean? We have essentially replaced physical particles and mysterious energies with the rigid, perfectly balanced geometry of number fields. Which leaves us with a truly provocative question to think about. If dark matter, dark energy, and cosmic expansion are all just macro-scale artifacts of an arithmetic balance sheet, are we actually living in a physical universe? Or are we existing inside an actively running,
error-correcting algorithm. It is a massive paradigm shift for sure. I really hope this mathematical masterclass has sparked your curiosity and left you wanting to explore the Adelic Langlands program even further.